Hello, Assalamu alaikum. I'm Yasir. Today, in this video, I will try to find contour plots. So for doing that, I solve the ordinary differential equations using the bvp4c. Uh, Now I will try to get some contour plots. For doing that, I will suppose that if n is the parameter in the momentum equation. So uh, I comment this for n is equal to 1 and I use n as a vector quantity. So in vector, I will give some values. So I use using some values for n. And then I start the loop. The loop, so that is j is equal to 1 to length of length of n. And because the variation is n, small n, so I will use 2 here. And now here I use another variable JSJ and then so that if I try to get the contour of F, so I will use 1 and then I use the contour plot into which one is F and so F I use the contour and so that number of contours are 30. So it's number of contours or it's just some quantity that related to contour. So if I run this thing, so if I run that, so this plot is so in this plot, the one where the I use that of thing I have to use one n and here one parameter is be the t, the eta. The t is the parameter correspond to eta. And another parameter is just a dimensionless parameter n. So that's so parameter t on the x-axis and parameter n on y-axis. So that's a plot. So now I also try to have some contours in temperature and a nanoparticle volume fraction. For doing that, I use this parameter instead of n. I use another parameter which is nt. So very nt, and then the scalar nt will not be used. The vector nt will be used. So here, so for nt, I would I nt of j here nt of j here nt of j. And then if I, for temperature, it is 4. For temperature, it is 4. So now I try to find the boot plot for this. If I run the code, so because it is n here, it's not that it's n T. So these are the contours for temperature. So I can also find the contour for the nanoparticle volume fraction with 6 here. So if I run the code, so I will get these values for nanoparticle volume fraction. On the x-axis, there will be its variable eta, and on the y-axis, it's the parameter nt, which is varying. So I end this video now. Yeah, this one.